sorry about that. This is a continuation of 14b. I had to answer the phone. I had an important call coming. Okay, so I'm reading my notes here on my thoughts. In this case, I think the alien wow signal has a sense of humor. Mixed with my wacky ideas, this one should definitely make you smile, the idea girl. I thought I'd tell you that cute little story. So Virgo equals Maya equals aliens. Okay? So I'm going to go back over to my notes here. So the next thing that came up from this equation of 0.0214 from the wow signal was this on-radio M87. Where's the M87? Okay. So it came up in French. That's what it looks like. So then I Google translated it. Images of the radio waves from the galaxy M87, which is Messier 87, located 50 million light years in the Virgo area. And that's why I wrote down, from February 1999, I wrote down Virgo. The Virgo area is where we think the Mayas people, the UFO travels, or where they live, okay? It says there's a black hole at the center of the galaxy, is at the origin of jet of particles. Radio waves are coming. The colors are distorted to the radiation. Okay, and that's from the NASA National Radio Astronomy Observatory, National Science Foundation. Okay. So, January 15th, 2012, 4:28 p.m. Eastern Standard Time. My thoughts. Wait a minute. I think I'm off track here. I just did a Google to find a nice image to put with all this, and I found out something related to outer space. Okay, so now we're going to look at black holes and relativistic jets, and guess what? It's a theory. Sweet. Okay, so I'm going to go over to here and show you what I found. So I was looking for pictures, and this came up, and I'm like, what? Because remember, I was looking for inner galaxies. So inner structure of an active galaxy. This is shock, relativistic jet, supermassive black hole is here, accretion disk, and then the opaque torus inner regions. Okay, that's what a black hole looks like, I guess. So we'll read about the relativistic jets are extremely powerful jets of plasma which emerge from presumed massive objects at the centers of some active galaxies, notably radio galaxies and quasars. Now you remember I was talking about in, I think, the last two videos, sorry, not the last two videos, it was back on the Maya section here. Video number 41 where we talked about a quasar radio space transmission coming from GR2148 plus 11. I didn't know what that was at the time. I didn't know what a radio quasar was. So I've learned since then what it is. Okay, so it's got something to do with these black holes. Okay, their lengths can reach several thousand or even hundreds of thousands of light years. The hypothesis is, so this is a theory, is that the twisting of the magnetic fields in the accretion disk collimates the outflow along the rotation axis of the central object so that when conditions are suitable, a jet will emerge from each face of the accretion disk. If the jet is oriented along the line of sight to Earth, relativistic beaming will change its apparent brightness. The mechanics behind both the creations of the jets and the composition of the jets are still a matter of much debate in the scientific community. It is hypothesized that the jets are composed of an electrically neutral mixture of electrons, positrons, and protons in some proportion. So at the time this was posted, they weren't sure about it. Let's check and look and see what relativistic beaming is. Okay, that's what it looks like. Plume, jet. So relativistic beaming is the process by which relativistic effects modify the apparent luminosity of emitting matter that is moving at speeds close to the speed of light. Okay? You can look it up on Wiki yourself if you want to read more about it. Okay? This come up, the elliptical galaxy of M87, I didn't know what it meant, so it's emitting a jet, relativistic jet right there. It's seen by the Hubble Space Telescope WFPC2 in the visible spectrum. Similar jets, though on a much smaller scale, can develop around the predation disk of neutron stars and stellar black holes. Okay? These are called microquasars. So I'm not going to read everything here. Okay, so the general hypothesis among astrophysicists is that the formation of relativistic jets is the key to explaining the production of gamma ray bursts. Okay? And back here I got rotating black hole as energy source. Because of the enormous amount of energy needed to launch a relativistic jet, some jets are thought to be powered by spinning black holes. These are two competing theories for how the energy is transferred from the black hole to the jet. Okay, and there's the different processes. So if you go to Wiki and type in relativistic jet, you can read more about it. Okay, so over here, let's go back over to this one. Okay, so go back to my theory. So the inner structure of an active galaxy comes up, and then relativistic jet leads to Centaurus A NGC 5128, and then Messier 83, known as the Southern Pinwheel Galaxy M83 or NCG 5236. Okay, so this comes up here. So this is what I learned about next. Is observation date is J2000 epoch. Centaurus, it's got the right ascension of 13 hours, 25 minutes, and 27.6 seconds. Declination is minus 43 degrees, 0.1 feet, 0.9 inches. Okay, and activity of the redshift distance. That's all from Wikipedia. So Centaurus A is also known as NGC 5128. So if you go onto Google Sky and type in NGC 5128, it should come up. I haven't tried it yet, but I'm assuming, because when I was in Google Sky, I kept seeing numbers like this, and I didn't know what it was. And I found out later it's the way they catalog the stars. So it's a prominent galaxy in the constellation of Centaurus. There is considerably debate. So again, here's another theory in the literature regarding the galaxy's fundamental properties, such as its Hubble type, lenticular galaxy, or a giant elliptical galaxy, and its distance. Okay, NGC 5128 is one of the closest radio galaxies to Earth, so its active galactic nucleus has been extensively studied by professional astronomers. The galaxy is also the fifth brightest in the sky, making it an ideal amateur astronomy target. So I thought and then just jump down here. The galaxy is only visible from low northern latitudes in the southern hemisphere. Okay, so a relativistic jet, which extracts energy from the vicinity of what is believed to be a supermassive black hole at the center of the galaxy, is responsible for emissions in the X-ray and radio wavelengths. By taking radio observations of the jet separated by a decade, astronomers have determined that the inner parts of the jets are moving at about 1/2 of the speed of light. So they're moving at half the speed of light, and we already talked about how fast the speed of light is. If you go back into the earlier videos, between 1 and 36, you'll find, just look at the titles, and the titles have the keywords for what we talk about in each of the videos, or look in the tags. If I can't fit it in the title, I put it in the tag. X-rays are produced farther out as the jet collides with surrounding gases, resulting in the creation of highly energetic particles. The radio jets of Centaurus A are over 1 million years long. As observed in other starbursted galaxies, a collision is responsible for the intense burst of star formation. Using the Spitzer Space Telescope, astronomers confirmed that Centaurus A is going through a galaxy collision by devouring a spiral galaxy. I don't know if I looked up that telescope. There, that's what it looks like right there. Huge thing. So it's an infrared space observatory launched in 2003. It's the fourth and final of the NASA Great Observation Program. Okay. Amazing what you find in a wow signal, eh? Okay, so my little arrows, I'm going to go back up to my thoughts. I'm going to finish telling you about my thoughts, and then we're going to talk about the people that are in my thoughts, okay? Okay, so I was wondering what all those NGC numbers meant in Google Sky. Now I have a good idea of what they are, the name of galaxies. The Galaxy Evolution Explorer GALEX is an orbiting ultraviolet space telescope launched on April 28, 2003. We're going to talk about that. And then now in the line 11 to 13 videos, we read about the Messier number prime and Messier 100. Interesting that all these galaxies are connected to one another, and man has been studying their radio signals for many years. Just on another note, I found a crop circle that has actually connected some of the Messier star formations that we've been studying. Pretty cool. That'll be in the next series of videos. I keep talking about what comes in the future, right? Okay, that'll be done after I'm done all this. Next is the wow theory stuff, and then I've got my SETI message, and then after that I'm working on crop circles, okay? So the GR2148 plus 11 quasar radar signal, I wonder if it's in the Virgo VLA radio telescope at February 1989 region. I'm not sure. Okay, a catalog of Messier objects from stars to comets in outer space. This is a great tool to use when looking at things in Google Sky. So if you're wondering what these NGC numbers are, I'm going to show you where to find them, and you can look at the pictures. It gives you all the ascension and declination numbers and everything there. And then we're going to talk about Pierre Méchain, sorry, I don't know how to say his name, discovered M83 in 1752, so that's the Messier 83, in 1752 at the Cape of Good Hope. Charles Messier added it to his catalog of nebulous objects, now known as the Messier Catalogue in March 1781. Now, I was really excited when I read this, because I didn't know that Charles, like I kept seeing why are they all called Messier 87 and 31 and stuff. I did not realize it was based on a man's catalog of stars. So, and I didn't even know what M83 meant. I actually thought he was talking about planets, and then I found out it's stars or objects in the heavens. And this man here cataloged them all. And we actually still, to this day, refer to this catalog when we're looking at the, like the Kepler region. He actually, I'm going to tell you something. Actually, it comes up in line 15. You want to check that one out. We're going to find out how Charles Messier found the Kepler region, the one that they're studying right now. Okay? So on June 16, 2008, NASA's Galaxy Evolution Explorer project reported finding large numbers of new stars in the outer reaches of the galaxy. So back in 2008, they found it, but they didn't get a chance to actually look at it. Now, with the Kepler satellite, they've actually sent a satellite out there, and it's exploring the regions and looking even closer. The funny thing is back in the 17th century, they were all cataloged as stars. In 2012, we now know that a lot of those stars are not stars, they're planets, and they're habitable. So that's very exciting to find out. That's why they're all jumping for joy down at SETI and NASA. Because they found out that some of the theories that some of the guys wrote back in the 17th century, and from now, it's been a big argument for years, that finally somebody is proving that they were right. Okay? So it has hitherto been thought that these are areas that lack the materials necessary for star formation. So basically, back in 2008, they found out that this area was a star formation area, that it had the power to do it. Back in the 17th century, there was a big argument as to whether or not it could form new galaxies. Okay, so we're going to go over to here. So this is your apoplectical galaxy M87, which I think I already showed you, right? I don't remember. Okay, it's emitting a relativistic jet as seen by the Hubble telescope WFP-C2 in the visible spectrum. Similar jets, though on a much smaller scale, can develop around the accretion disk of neutron stars and stellar black holes. These systems are often called microquasars. Yeah, we did read this before. Okay, so that's what it looks like. This is the Centaurus A, which we mentioned. Okay, go to Wikipedia, find that out. And oh, here we go. That's a little more. It's a prominent galaxy in the constellation of Centaurus. There is a considerable debate in the literature regarding the galaxy's fundamental properties, such as its Hubble type. And we read that too. Okay. So this is Charles Messier. This is the man that found these stars and started a catalog about them. As you can see, he was born in June 26, 1730, and he died 12th of April, 1817. He was a French astronomer, most notable for publishing an astronomical catalog consisting of deep sky objects such as nebulae and star clusters. It came to be known as the 110 Messier objects, so he only cataloged 110 of them, but we still refer to it. The purpose of the catalog was to help astronomical observers, in particular comet hunters such as himself, distinguish between permanent and transient objects in the sky. The Messier objects are a set of astronomical objects first listed by French astronomer Charles Messier in 1771. The original motivation of the catalogue was that Messier was a comet hunter and was frustrated by objects which resembled but were not comets. So he was looking for comets, and instead he finds these stars. He doesn't realize that this is a great find back then. He therefore compiled a list of these objects in collaboration with his assistant Pierre Méchain. A similar list had been published in 1654 by Giovanni Hodierna, but had no impact and was probably not known to Messier. So these are the comets, 13 comets that he discovered. They're on Wiki under Charles Messier. Okay, and there's Messier 83, and I'm running out of time for this video. And let's see, there's quite a bit more. So guess what? We're going to make a number C for 14, okay?